CSIR-CECRI, Central Electrochemical Research Institute, is one of a chain of 38 national laboratories under the aegis of the Council of Scientific and Industrial Research (CSIR) in New Delhi. Founded on 25th of July 1948 at Karaikudi in Tamil Nadu, CSIR-CECRI came into existence in January 1953. During the last 50 years, CSIR-CECRI has been recognized as the premier institution for research and development in electrochemical science and technology, not only in India but also in Southeast Asia, with a total strength of over 600 personnel comprising of scientists, engineers, technologists, skilled workers, administrative and other staff, with a combined laboratory space of 400,000 square feet in a campus of 300 acres. There are 3 extension centers for CSIR-CECRI located at Chennai, Mandapam and Tuticorin. Electrochemical Power Sources (ECPS). We all know that energy can neither be created nor be destroyed, but one form of energy can be converted into another form of energy, and this is where CSIR-CECRI's chemical energy to electrical energy conversion and storage efforts comes to limelight. For e-mobility and e-gadgets, we have the indispensable choice of lithium batteries only for the time being. In a step towards self-reliance and under our PM's Make in India program, we have installed India's first pilot prototype lithium-ion fabrications facility in CSIR-CECRI Chennai unit. A program called TAP Sun Technology and Products with Sun Utilization Network has been started in 2011, where CSIR-CECRI spearheaded the Store Solar component. CSIR-CECRI Chennai unit recent success story includes demonstration of high-temperature air-cooled stack to TVS Motors, Hosur, development of 3 kW water-cooled PEMFC stack and validation in Pathol Ganga site of Reliance Industries Private Limited, Mumbai, and 1 kW air-cooled PEMFC stack to IGCAR, Kalpakam. Many membrane electrode assemblies (MEA) of different area and its process parameters are optimized at CSIR-CECRI Madras unit through different forms of decal, spray and brush coating. The best optimized version of MEA for its testing at the single cell level is done initially to benchmark the performance criteria. CSIR-CECRI Madras unit has sophisticated electrochemical characterization facilities for basic research to understand the catalytic activity of the electrocatalyst, ionic conductivity of the membranes, and fuel cell test station and assembly units for testing cells and stacks of various capacities. CSIR-CECRI is also working on indigenous zinc bromide redox flow battery with a target capacity of 500 watts. This is for the grid-level storage of energy harnessed from solar and wind energy. Towards testing of batteries, CSIR-CECRI has created NABL-accredited CSIR BP Tech Battery Performance Testing and Evaluation Center in 2014, a unique facility for assisting battery industries in quality management. Solar energy can be stored in batteries or in the form of H2 by splitting water. CSIR-CECRI has been involved in R&D program on PEM-based water electrolyzer to produce pure hydrogen and oxygen. Most of water samples collected near industrial hubs especially are found to contain toxic elements like fluoride, arsenic, etc. When such a water is consumed, obviously the consequences are alarming due to hazardous components. CSIR-CECRI has developed electrochemical defluorinator, dearsenator and electrochlorinator. The electrochemical defluorinator consists of electrolyzer, settling tank and filter. This reduces the fluoride from any level to 1.0 ppm. This technology was transferred to various clients in India. CECRI, in one of its attempts to mitigate water pollution using electrochemical techniques, deserves a special mention. To strengthen the hands of agricultural research initiatives through electrochemistry, here comes CECRI's attempts to launch a NPK sensor, which is an indicator to proceed further. Modern agriculture requires technology which can afford rapid and sensitive analysis of soil fertility. This particular development is expected to bring a huge societal impact. Another important area is about the waste to wealth driven electrodes. For example, food waste could be converted into electricity by microbial fuel cells, MFCs. The power output obtained from our MFCs is sufficient for running digital clocks, lighting low-power LEDs and powering calculators. CSIR-CECRI has developed a number of electro-organic processes such as electrochemical oxidation of glucose to calcium gluconate, salicylic acid to salicylaldehyde, toluene, as well as substituted toluenes to corresponding benzaldehydes, electrochemical perfluorination, ECPF. At present, CSIR-CECRI is the only laboratory in the country having ECPF facility. We do have a technology on dyeing of cotton fabrics. That dye is the most popular among dye classes used for coloration of cotton fabrics, particularly when high fastness standards are required to light washing and chlorine bleaching. Further, we have developed 5-compartment membrane electrochemical process for the removal of chlorides from amino acids, salt mixtures and chlorides from diamine hydrochlorides. To our credit, we have developed an electrochemical process for the preparation of D-arabinose with the yield of 85%, an important intermediate involved in the synthetic route of vitamin B2. Thermal barrier coatings, TBCs, find vast applications in the field of space, defense and aerospace sectors. CSIR-CECRI is developing multi-layered TBCs. We work on the development of core shell nanoparticles for photocatalysis. The production of the gas hydrogen is confirmed using chromatography. Our scientists contribute to surface engineering for device applications under which thin films of transparent conducting oxides, transition metal nitrides and bioceramics are being developed. 3D metal printing technology is used to fabricate custom-made metallic bone and dental implants with nanotopographies for faster osseointegration. Biomaterials Group. In India, medical device manufacturer in orthopedic and dental field are very limited. Most of the surgeons have to depend on imported implants which are very expensive for a common man. You were watching the glimpse of research activities of CECRI, the research institute where lights are not put off and labs are never closed, because researchers of all age groups work throughout the day and night, and solutions are being offered to very many challenging and alarming issues of this society using electrochemical techniques. To experience CECRI, do visit us in person. And CECRI, the ultimate electrochemical solution provider.